There's a creature at the bottom of the ocean that hasn't eaten in 5 years. Not 5 days, not 5 weeks, 5 years. And it's not dead. It's not even close to dying. In fact, it's doing just fine. Thank you very much. Scientists are watching it, studying it, trying to figure out how the hell this is even possible. Because if we could crack this code, if we could understand how this thing survives when everything we know about biology says it shouldn't, well, that changes everything. Meet the giant isopod, nature's most patient diner, the deep sea's version of that friend who says they're not hungry and then eats half your fries. Except this friend doesn't eat your fries, or anything else, for years. Now before you start thinking this is just some weird shrimp, let me stop you right there. The giant isopod looks like someone took a pill bug, you know those little roly-polies you played with as a kid, and hit it with a growth ray. We're talking about a creature that can reach 20 inches long and weigh up to 3.7 pounds. That's the size of a small cat. A cat made of armor plating and existential dread. And here's where it gets interesting. This thing lives in places where food is so scarce that going years without eating isn't just a party trick. It's Tuesday. The deep ocean, specifically the bathypelagic and abyssopelagic zones, which is scientists speak for really deep and absurdly deep, is basically a desert. But instead of sand, it's water. It's darkness. Pure, crushing, eternal darkness. We're talking depths of 550 to 7,020 feet below the surface. At those depths, the pressure is so intense it would crush a human like a soda can. The temperature hovers just above freezing. And sunlight? Forget about it. Sunlight gave up trying to reach down here about 600 feet ago. So what does a creature eat down there? The short answer is whatever falls from above. Dead whales. Dead fish. Dead squid. Organic matter that drifts down like the world's most depressing snow. Scientists call it marine snow, which sounds poetic until you realize it's literally corpse confetti. But here's the problem. Marine snow doesn't fall on a schedule. There's no breakfast, lunch, and dinner in the abyss. Sometimes a dead whale lands on your doorstep. Jackpot. Sometimes nothing happens for months or years. And that's where the giant isopod's superpower kicks in. Let's talk about that 5-year fast. In 2007, a giant isopod named Number 1, because scientists are incredibly creative with names, arrived at the Toba Aquarium in Japan. The staff tried feeding it. Number 1 looked at the food, considered its options, and said no thanks. Not metaphorically. It literally refused to eat. For 5 years and 43 days, this creature didn't consume a single thing. Not one bite. Not one nibble. Nothing. Then, on February 14, 2014, Valentine's Day, Number 1 died. The cause of death? Probably starvation. Though the scientists weren't entirely sure. And that's the wild part. Even after an autopsy, they couldn't definitively say whether the isopod died from starvation or something else entirely. Its body had adapted so completely to not eating that the normal markers of starvation weren't even there. Think about that for a second. 5 years without food and the scientists couldn't even confirm it died from not eating. That's like finding someone who hasn't had water in a month and discovering they're perfectly hydrated. It breaks every rule we understand about metabolism and survival. So how does this work? How does a creature survive when it should be dead a dozen times over? The answer lies in something called extreme metabolic depression, which sounds like what happens to you on a Monday morning, but it's actually way more impressive. Giant isopods can slow their metabolism down to levels that would make a sloth look hyperactive. We're talking about dropping their energy consumption by up to 20% compared to shallow water species. Every process in their body shifts into the biological equivalent of power-saving mode. Their heart rate drops. Their breathing slows to almost nothing. Cell regeneration grinds to a crawl. Waiting. Just waiting. And here's the kicker. They can snap out of it the moment food appears. No warm-up period. No adjustment time. Food shows up. Metabolism kicks back into gear. And it's dinner time. But metabolic depression is just part of the story. These creatures have other tricks up their, well, they don't have sleeves, but you get the idea. First, let's talk about that armor. Giant isopods are covered in overlapping segments of protective plates made from calcium carbonate and chitin. It's the same stuff that makes up crab shells and insect exoskeletons. But the isopod's armor isn't just for defense against predators. It's also incredibly efficient at conserving energy. That hard shell requires very little maintenance. It doesn't need constant repair like soft tissue. It just sits there, being tough, using almost no resources. When a predator shows up or conditions get too harsh, the giant isopod can roll into a ball, just like its tiny pill bug cousins. This behavior, called conglobation, protects all its vulnerable parts and creates an armored sphere that's nearly impossible to crack. It's like carrying around a personal panic room. Then there's the digestive system. Oh boy, the digestive system. Giant isopods have what scientists politely call an expandable stomach. That's a nice way of saying they can eat until they look like they swallowed a bowling ball. When food does show up, these things don't nibble delicately. They gorge. They stuff themselves until they can barely move. Because who knows when the next meal is coming? Could be tomorrow. Could be never. There are accounts of giant isopods eating so much, they literally can't swim away from predators afterward. They just sit there, bloated and vulnerable, like you after Thanksgiving dinner. Except the stakes are slightly higher, but it's worth the risk. Storing that much energy in one go means they can survive exponentially longer until the next meal. And we need to talk about their feeding behavior, because these things aren't picky. At all. They're scavengers, sure, but they're also opportunistic predators. They'll eat dead fish, dead crustaceans, dead whales. But if a slow-moving sea cucumber waddles by, the isopod will absolutely take a live meal. They've been observed attacking and eating live fish, sponges, and other slow-moving creatures that can't escape. They have powerful mandibles, which are basically underwater bolt cutters, capable of tearing through tough flesh and even bone. And they don't waste anything. When an isopod feeds, it extracts every possible calorie from its meal. Efficient doesn't even begin to cover it. But here's where it gets weird. And we're already talking about armored sea bugs that don't eat for years, so that's saying something. Giant isopods have been observed engaging in something called necrophagy, which is the fancy term for eating the dead. But not just eating them, they swarm them. When a large carcass lands on the ocean floor, giant isopods can detect it from considerable distances using their highly developed sense of smell. Well, not smell exactly. They have chemoreceptors on their antennae that detect chemical signatures in the water. Once they find a carcass, they don't fight over it, tearing off chunks of flesh in what can only be described as an underwater buffet. It's cooperative feeding without the cooperation. Everyone just shows up and eats until they physically cannot eat anymore. And speaking of showing up, let's talk about how these things move. Despite their size and armor, giant isopods are surprisingly mobile. They have 7 pairs of legs, 14 total, which they use to crawl along the ocean floor. But they can also swim. Sort of. It's more of a fluttering motion, where they flip their bodies and use their legs and tail to propel themselves through the water. It's not elegant. It's not fast, but it works. The thing is, they don't move much. Why would they? Movement burns energy, and energy is the one resource you absolutely cannot waste in the deep ocean. So giant isopods spend most of their time sitting perfectly still, conserved in one spot, waiting for their chemoreceptors to pick up the scent of food. They're the snipers of the deep sea. Patient, motionless, and ready to strike when the opportunity presents itself. Now let's address the elephant in the room. Or rather, the giant isopod in the ocean. Why don't we see these things more often? If they're so good at surviving, why aren't they everywhere? Simple. They live in one of the most inhospitable environments on Earth. The deep ocean isn't just dark and cold, it's pressurized. At 2,000 feet, the pressure is about 60 times what you experience at sea level. At 7,000 feet, where some giant isopods live, it's over 200 times atmospheric pressure. That kind of pressure would collapse your lungs, crush your bones, and turn you into human soup in seconds. But giant isopods have evolved to handle it. Their bodies don't have air spaces that can be compressed. Their cells are adapted to function under extreme pressure, and their hard exoskeleton distributes that pressure evenly across their body. To them, 200 atmospheres of pressure is just normal. It's what they're built for. This also means they can't survive in shallow water. Bring a giant isopod to the surface too quickly, and the rapid pressure change would kill it. They're locked into their environment. adapted so specifically to the deep ocean that they can't leave even if they wanted to. And that brings us to an interesting point. Giant isopods are not a single species. They're a family. There are around 20 recognized species of giant isopods in the genus Bathynomus. The most famous and largest is Bathynomus giganteus, found in the Atlantic Ocean and Gulf of Mexico. But there are species in the Pacific, the Indian Ocean, and even the Southern Ocean around Antarctica. Each species is slightly different. Some are larger, some live deeper, some have different feeding preferences. But they all share that core adaptation, the ability to survive prolonged starvation through metabolic depression and opportunistic feeding. It's such a successful strategy that it's appeared multiple times across different species and different oceans. Evolution doesn't repeat itself unless something really works. But here's the question scientists are obsessing over right now. How long can they actually survive without food? Number 1 made it 5 years. But was that the limit? Or could they go longer? And more importantly, what are the implications for understanding extreme survival biology? Because this isn't just about weird sea bugs. This is about understanding the fundamental limits of life. If a creature can shut down its metabolism to this degree and still maintain essential functions, what does that tell us about hibernation? About cryogenics? About long-term space travel? NASA is interested in giant isopods. Not because they want to send them to Mars, though that would be hilarious, but because understanding how these creatures survive in such extreme conditions could inform how we keep astronauts alive on multi-year missions. Even partially, that changes the math on interstellar travel entirely. Medical researchers are interested too. Understanding how giant isopods avoid muscle atrophy and organ damage during prolonged periods of inactivity could revolutionize treatment for coma patients, people in long-term care, and anyone facing extended immobility. And there's the aging question. Giant isopods appear to age very slowly. Some estimates suggest they can live for up to 20 years or more, though studying their lifespan in the wild is nearly impossible. But if slowing metabolism also slows aging, and the evidence suggests it might, then these creatures are walking, or rather sitting very still, laboratories for longevity research. Of course, none of this answers the question everyone really wants to know. What do they taste like? I'm serious. People have asked this. And yes, people have eaten them. In parts of Asia, particularly Japan and Taiwan, giant isopods are occasionally served as a delicacy. They're typically boiled or steamed, just like lobster or crab. The meat is reportedly similar to crab, though slightly chewier and with a faint taste of the deep ocean, which is probably code for they taste like the bottom of the sea. There's even a giant isopod ramen shop in Japan. The same place where Number 1 died, partnered with a local restaurant to create a ramen bowl served with an entire giant isopod perched on top. It's equal parts impressive and deeply unsettling. The kind of meal where you're not sure if you should eat it or apologize to it first. But let's get back to the science. Because there's still so much we don't understand about these creatures. For example, reproduction. Giant isopods are believed to reproduce slowly, with females carrying fertilized eggs in a pouch on their underside, similar to other crustaceans. But the exact details are murky. How often do they reproduce? How many offspring survive? How long does it take for an isopod to reach maturity? We have theories, but very few confirmed observations. Part of the problem is that studying deep-sea creatures is incredibly difficult. You can't just pop down to 3,000 feet with a snorkel and a notebook. You need submarines, remotely operated vehicles, sophisticated cameras, and a lot of funding. Most of what we know about giant isopods comes from specimens that have been caught, usually accidentally, in deep-sea trawling nets. Keeping them alive in captivity is challenging. They need cold water, high pressure, and the right food at the right time. Aquariums that successfully maintain giant isopods are rare. The Toba Aquarium in Japan is one of the few places where you can see them, and even then, they're notoriously difficult to keep healthy, which brings us to the conservation question. Are giant isopods endangered? Honestly, we don't know. We don't have enough data on their population numbers to make that determination. They live in an environment that's largely inaccessible and unstudied. What we do know is that deep-sea trawling, pollution, and climate change are all affecting deep ocean ecosystems. And when you live in an environment where food is already scarce, Any additional stressor can be catastrophic. There's also the issue of ocean acidification. As the ocean absorbs more carbon dioxide from the atmosphere, the water becomes more acidic. This affects creatures with calcium-based shells and exoskeletons, like giant isopods. If the water becomes too acidic, their armor could weaken, making them more vulnerable to predators and environmental stress. But here's the thing that really gets me about giant isopods. They're survivors in the purest sense of the word. They live in a place where almost nothing else can. They eat food that barely exists. They wait in the dark, patient and still, for opportunities that may never come. Fossils of ancient isopods date back to the Carboniferous period, over 300 million years ago. These creatures have survived mass extinctions, climate shifts, and every other catastrophe the planet has thrown at life. They watched the dinosaurs come and go. They were here long before humans and will likely be here long after we're gone. There's something almost philosophical about that. In a world obsessed with speed, productivity, and constant consumption, the giant isopod exists as a reminder that sometimes survival means doing less, waiting more, conserving everything. It's the ultimate minimalist, living proof that you don't need much to endure. Just patience, adaptation, and the willingness to wait for your moment. So the next time you're stressed about meal prep or worried about missing lunch, remember number 1. That absolute unit of an isopod who looked at food for 5 years and said, "Nah, I'm good." Who survived in conditions that would kill almost anything else. Who reminded us that life finds a way, even in the darkest, coldest, most impossible places. The giant isopod, nature's most patient creature, the deep sea's ultimate survivor. A living armored testament to the fact that sometimes the best way to win is to simply outlast everything else. And honestly, that's kind of beautiful.